this is the agenda for our today's presentation. All right, so this is the agenda. We'll be looking into AWS IoT core basics. Next, followed by architecture design. We'll also look into the hardware design, and we'll explain you how you can develop a sustainable IoT architecture, followed by security, and then we'll be looking at the demo. Okay. So starting with the sustainability and environmental compliance for IoT. So basically, see, sustainability for me is like a balance among four elements, we can say, like resource exploitation, investment direction, and technological development. Okay, and the last one is institutional change. So all four must be in harmony. Okay, while they enhance both current and future human needs. So I remember in 2015, United Nations released 17 sustainability development goals, okay, which provides excellent starting point for sustainability. So if you are going to develop an IoT product, okay, and then I will request you to go through those 17 sustainable development goals. We call it SDGs. So it will help you to follow this sustainable development. So this include like high level goals such as uh, affordable and clean energy, and there are followed by around more than 15 other goals, which can be further broken into more detailed objectives, such as let's say if your IoT product is related to agriculture, okay, then you can improve, you know, you can improve your global rate of energy efficiency based on the agriculture practices. Next is sustainable engineering. Okay, so basically in achieving this sustainability, engineers play a very important role. Okay, uh, which also includes like life cycle analysis, pollution prevention, and design of sustainable. Uh, we call it disassembly and recycling. Okay, so whatever IoT product you are going to develop, it should be recycled. It can be recycled easily. Along with that, it should be energy efficient, and of course, it should be reusable. Okay. So let's say you have developed an IoT product for one business use case, and later on, if a business use case changes and there are around billions of devices, that device should adapt the new business, uh, business process. So, like, let's say there is a firmware, okay, which is being used to follow those new business practices. Then those 17, like whatever those billion devices are there, IoT devices, they should be easily, like they can be easily loaded with the new firmware, okay, without changing those IoT devices. So they should adapt the new business process in terms of firmware and uh, energy efficiency. Okay. So yeah, and apart from that, while manufacturing these IoT devices, they should be, they should not emit CO2. So recently, I was looking into one of the webinars for IFY Electronics for You, and where they came up with PCB design. Okay, PCB design for which does not require soldering. Okay, soldering is a process where you join up all those components on for any of your electronic device. Let's say there are capacitors, transistors, so they require soldering. But one of the scientists came up with a new PCB design that does not require this soldering flux and all. Just put all the components on that PCB and that's it. Like and just just start up that device. So it automatically got soldered. And in the behind the scenes, what it used to do is, it used to it used to emit some high temperature rates. So those components automatically got soldered, and there was no need of, you know, soldering it manually. So that saves a lot of time. Of course, Just think of a case where a big factory is there and they are manufacturing billions of devices in an year. Okay, so just think how much soldering flux, like lead, because soldering contains lead. Okay, and of course flux emits some smoke, which is dangerous. And if an individual is soldering, and they may inhale that smoke and come up with some diseases. So uh, that's what sustainability is. And next is types of IoT. So number one is IoT, Internet of Things. Can somebody tell me what is IIoT? So
Industrial Internet of Things.
Industrial.
yeah, so it's industrial IoT, and next is IOMT, which is used for medical and healthcare. Okay, so see this IIoT and IOMT behind the scenes they follow the IoT kind of a framework, but of course let's consider the term for IOMT. Okay, so in medical IoT devices, they need to be available 24/7. Okay, so the design, the way they get designed, it should be a modular design. They follow certain framework for energy efficiency, and so that's the difference. Like in industrial IoT, they are being used in industries. Okay, so they are used in industries and they provide efficient manufacturing, intelligent manufacturing, we can say. Okay, so these two are kind of the same. Behind the scenes, they follow IoT, but you know their architecture is different. Like the way they are manufactured, the way they both like multiple modules interact with each other, there is a difference in terms of that. Okay, these are some of the use cases for IoT, like increased productivity. Okay, so as I told you right in the previous slide, industrial IoT. So industrial IoT should provide increased productivity. Next is energy management. So the IoT is being used in energy management as well. Remote healthcare, connected vehicles. You see Tesla, right? So it's kind of connected vehicles. Higher crop yield. So in agriculture also they are using IoT for getting higher crop yield. Inventory tracking, enhanced safety, smart home. So for inventory tracking, I was looking into one of the IoT use case, and what they were doing is they were installing some of the IoT devices to track containers that that are being shipped. Okay, so there was a live tracking of temperature. Apart from that, the location of the this particular container that is being transported in ships. Also they were tracking the like let's say if there is a hard shake on that container. Okay, they were recording that shake as well, that how much shake was there, to identify at what location this shake was there. And let's say if it is transporting a big costly vehicle or maybe some glass related items, then they can trace it. So there was a live tracking using satellite that they were performing on these containers. Okay. And yeah, smart home. There is a use case for smart home like Alexa, what we already all know. Okay. So behind the scenes, of course, Alexa is also using this AWS IoT and Lambda. I will explain you what is Lambda in next slides. So what customers are doing with AWS IoT? Okay. So these are things they are doing, like data driven. Okay, they are making intelligent decisions based out of this, increased efficiency, better relationships with customers, and better products are coming out. And of course, using this AWS IoT, since you are saving 80% of the development cost, new business models can be easily adopted. So the result is operational efficiency. IoT data decreases OpEx. Revenue growth is there. IoT data drives business growth. So this is the IoT virtuous cycle. So see, this is a circle. Okay. So here the IoT devices are located at the edge. All right. This data, this devices can be controlled, okay, using AWS IoT or any other cloud environment, okay. And they provide analytics and analytics using machine learning and AI, okay. And using all these three, using this cycle, you achieve a goal, okay, which is a successful goal, you can say, okay. And of course, yes, using using this IoT, okay, you can control where your devices are located, how like you can secure your devices. That I will explain you in the next slides. These are some of the common challenges for device software. Okay, say like robust processing and data management, remote deployments and over-the-air updates, fleet monitoring and management. So as of now, the processing is a challenge, and of course the data management. And if we see the remote deployments, okay, let's say if a company wants to deploy a million devices, okay, and they want to provide over the air updates, then it is very challenging at the moment if you're not going to use the cloud, okay, like any services like AWS IoT cloud. Of course, fleet monitoring and management is also a challenge. Like, let's say if you want to onboard devices and manage all of them, like let's say at a time, or you want to deploy some devices in a specific region. Let's say a company operates three locations in Europe, Asia, and Americas. Okay, and if they want to deploy, uh, like let's say if they want to deploy a firmware in Asia region because of some compliance reasons, okay, then it is a big challenge at the moment. So AWS IoT solves that. About the IoT core basics. So see, IoT core is a service in AWS. Okay, it's a managed cloud service that lets connected devices easily and securely interact with the cloud applications and other devices. Using AWS IoT core, you can support billions of devices and trillions of messages. And it can process and route those messages to AWS endpoints and to other devices reliably and securely. Okay. So I'll walk you through all in this service using my AWS account. Okay. So today we are going to consider one of the business use case. Okay. So whatever AWS IoT device I have developed that I am going to present is based on this use case. So a security company is manufacturing the security products, and they want to introduce cloud-based solutions. They have very limited time to market this product. Okay. Existing products that they are having shorter lifespan, and these products are having high failure rates. A company is looking for secured, robust solution. Okay. So we are going to solve this business use case in next slides. So based on this business use case, I came up with this architecture design. I will walk you through this architecture design, but let me first show you this AWS IoT core service. Okay. So I'm logged into my AWS management console. Okay. So here there is a service called IoT core. So as you can see, it states IoT core securely allows you to connect, test, and manage your IoT devices. Okay. AWS IoT can support billions of devices and trillions of messages like what we saw. And of course, it's very secured. You can connect individual devices, and see, there are also templates available. So let's say if you want to board millions of devices, then you can use those templates to onboard them at a time. You can also test this IoT devices, okay, and using MQTT, okay. So behind the scenes, it uses MQTT, which is MQ telemetry transport, okay, which is used to communicate with this IoT. It also allows you to manage your IoT solutions all in one place using tools for managing devices, remote actions. You can also perform remote actions, okay? And also apply some security and write applications beyond based of that, okay? So yes, on the left hand side, you can see first option that is available over here is for monitoring, okay? So this allows you to monitor your IoT devices. Let's say if you have bifurcation by region, then it shows you uh, what messages are being transported, because the IoT devices sends a lot of data, okay? And if you want to monitor based on data, on region, on based on device, you can filter and monitor all your IoT devices uh, in this using this service. It also provides you an ability to design and develop intelligent dashboards, okay? So behind the scenes, it uses machine learning, okay? So using uh, this data that from the monitoring, you can apply security and perform a lot of other business tasks. Next is the connect menu, which allows you to connect one device and connect many devices. Okay. So as I told you, right, if you want to onboard multiple devices, you can use templates, which are known as provisioning templates over here. You can also use bulk registration. Okay. So if you want to register multiple devices at a time, you can use this. Let me click on this and show you. So here you can create the provisioning template, and there are multiple options based on your business use case. Okay. Next is bulk registration. So see, this is the provisioning template I was talking about. Okay, it's kind of a JSON template that you can use. You can also, let's say, if you have a parameter file located in S3. So for all those who do not know what is S3, S3 is like a shared storage provided by AWS, and you can put that parameter file and choose an appropriate role over here and start registration. So what it's going to do is it's going to onboard all your devices at a time. So you don't need to register one by one. Okay. Next is this connect one device. So if you have a single device, you can use this wizard and you can register your device. Okay. Next is MQTT test client. So let's say if you want to test your MQTT, like your device, okay, you can test using this thing. Device location is a new thing that is there, like a new option that is being shown by in AWS. So what this does is, let's say if your device is emitting some latitude longitude data, okay, and you want to perform some testing on basis of that, then you can use this option. Okay. So this was recently introduced. Next is the manage option. It shows thing groups, thing types, and fleet metrics. Okay. So things. Okay. So see, an IoT device is a thing. Okay. So this is the thing that I have registered over here. This is the IoT device that I have registered here. Okay. I have named it as ESP8266, which is a board that is a Wi-Fi board, you can say. So coming to the security part, see, we have issued a certificate that has been imported into this device. I will show you where it is imported. It is imported in the firmware. Thing groups, device shadows. Thing groups is like if you have a group, let's say if you have 10 devices that are working at a same location, then you can group and put like you can create a group and add it in the group. Okay. So device shadows allows all the connected devices to sync the state with AWS. You can also get update and delete state information about this thing using HTTPS and MQTT topics. Okay. You can also interact but we won't be looking into this further. Activity, currently it has no messages. That's why it's not showing over here. Jobs, if you want to perform some automation, then you can create a job over here. Okay. Alarms means, let's say you have defined certain threshold and you want to receive a notification on your cell phone or on your email based on this IoT device data. Let's say if the IoT device is measuring the temperature, okay, and you want to receive a notification if it reaches 100 degrees, then you can define an alarm over here and get a notification based on that. Defender metrics. So defender metrics is a kind of a metric that is being, outputted by AWS Device Defender. So AWS Device Defender is a kind of firewall. Okay. What it does is it sits in front of your AWS device communication, and it checks like if any hacker is trying to hack your AWS like IoT device, then it's gonna, this metric will show up over here. If there are multiple authorization failures, connection attempts, let's say if hacker is trying uh, like multiple connection attempt to your IoT device, then it's gonna show over here. If there are multiple disconnects, message size maximum, message size minimum. So these are all the metrics you can monitor over here. Okay. Okay. Next is thing groups. You can create a group over here. You can create static group and dynamic group, but I think static group is what we need. Create a thing group. Okay. And from here, if you go in the thing option, you can add this device to a group. Okay. Thing group, and you can add it to a group. Okay. This should show up now. So that's how you can group multiple IoT devices. Thing types. So you can define a type, say like a generic name, we can say. Okay. Fleet metrics, as I told you that, right? These are the fleet metrics. So it shows up multiple metrics related to your fleet. Next comes up the green grass. So there is also one like this is a kind of a new uh, enhanced option available in IoT called green grass. So this lets you achieve the uh, sustainable point. Okay, lets you achieve the sustainability. So what it does is it allows you to manage multiple devices at a scale. It allows you to load firmware on multiple devices. It lets you build and deploy multiple devices. Okay. So basically, what we need to do for in this IoT green grass is, there is a client software that you need to install in your IoT device, and that client software allows you to, you know, uh, I mean that will act as a core part. So that will interact with this IoT Greengrass service, and it will allow you to load firmware, like manage device software and everything. Okay. It also allows you to monitor your device state, like if your device module is failed, let's say if your device is containing an LCD module or RFID module, and if that RFID means uh, you know scanning a card. I will show you that in the working demo, but I'm just giving you an example. If a particular module fails, then you can quickly see in the IoT Greengrass uh, menu, okay, in the monitoring state. So it has various options like core devices, components, deployments. So you can perform deployments as well. So I don't need to, let's say, if a new firmware or new device software is there, then I don't need to send my representative to client's place to load this, to deploy the software. Okay, it can be loaded from over here just in a single click. You can perform remote actions as well. If you have some jobs, then you can write a job for that in an individual job using the job templates as well and secure tunnels. You can also perform message routing. Okay, you can define some rules. I have defined this rule. I've explained you what it does. Okay, destinations. So it enables you to send data to other services that are not integrated with AWS. So the main benefit of this green grass service, okay, is it allows you to, use AWS services from your IoT device. So let's say if you want to access S3, which is a shared file service from your IoT device, you can access it directly from there. So that's what the benefit is. All right, so now we'll go back to the architecture. So this is the architecture design I have made. So see, looking at this business use case, I came up with a product, okay, which is kind of a security product, we can say. What it does is, uh, there are certain RFID cards available. What you use in your office, right? You used to swipe that card on that scanner. Okay, so we call it as an RFID scanner. And when a user in this current use case, when the user is going to scan an RFID card on that device, the complete authorization will be happening at the AWS side. Okay, so we are going to use AWS IoT core service. Apart from that, we are going to use the lambda service and the database. Okay, and see, this architecture is not just limited to one use case. You can use it in any IoT use case. And this has been highly, I have tested this, and it can scale to billions of users, okay, billions of IoT devices. And it is highly resilient and stable, okay. So coming, let's look at this architecture one by one, okay. So let's look at the DynamoDB first. So in this DynamoDB, what you see over here, I'm storing the RFID IDs. Okay. So we are gonna go back to the home page and look out for the DynamoDB service. Okay. I already have a database in place. I've named it as access card data. Okay. So this is my table. And here you can see one ID is there. Okay. So whatever RFID chip you are using, like let's say even our office ID cards, okay, they have some kind of this this kind of ID in it. Okay, some can be eight, like much longer, like some are 16 digits long, or some are 4 digits long. Okay, 4 to 8 digits. So this is the card that we are storing over here. Now, what is going to happen is when a user is going to scan the card, okay, this card data will be read from the IoT device, like RFID scanner. It's going to send it using this AWS IoT core service. Is going to send it to the lambda function. This lambda function is going to grab the existing data, like whatever card ID is being stored. It's going to match the data and return a response to the AWS IoT core stating that access is granted or not. And then the same message we are going to display it in the LCD of the device. Okay. And of course, this database is also highly scalable. The reason why we are using DynamoDB is we don't have much data at the moment, but this is again highly scalable service from AWS. So it can also scale to billions of users and devices. Okay. So one thing I want to show you over here for this thing. Yeah, the update settings. we are using currently provisioned mode. Okay. So let's say if you want to scale your database based on demand, okay, then you can use this on demand. What it's gonna do is, see, if you have billions of devices, okay, they are all gonna interact with this same database, okay, at a time. Now, if you are using provision, then it may crash your database. So I'll suggest you, if you are gonna if you're if, if you are having multiple IoT devices, let's say billion in scale, go for on demand, okay, and save settings. It will scale, like this whole architecture will be highly scalable after that. But currently we don't have much data, so that's the reason we have defined provision capacity mode. Okay. Coming to the next part, which is the lambda. Okay. So here is where our business process will be defined. So lambda is a service provided by AWS, uh, which is known as a serverless service. Okay. Serverless in terms of there are no servers required to use this service. Of course, AWS uses some servers at the back end, but from the user perspective, no servers are required. That's why we call it a serverless. Okay. We have access checker. Okay. So here is the function. So as you can see, it is interacting with the AWS IoT. Okay. And here we have the same kind of uh, mapping in the architecture. So here is the code that I've written in Python. Okay. So I'll walk you through the code. So we are importing JSON and Boto3. So Boto3 is kind of a library that's being used to interact with AWS services from your code. Okay. So using your code, you can interact with the IoT service. So here we are interacting with the IoT data. Okay. And we are also connecting to the DynamoDB. Okay. So yeah. Next is we are reading the message. Okay. So the message is, see, our RFID, like whatever our device is there, right? Access device that we are gonna use, it's gonna pass a parameter of RFID ID. That 4-digit ID we saw, a card ID, we can say. Okay, it's gonna pass this message and it's gonna read it in this, store it in a variable. We are initializing the authorization message as access denied. Okay. Next is we are getting the resource for the DynamoDB using Boto library. Okay. We are accessing the table access card data, what we just saw in the DynamoDB. Okay. And we are getting the card ID, the parameter, the column that we are storing. Okay. The key. And we are getting the value from there. And that's it. If this value is existing, okay, we are checking if this value is existing in the DynamoDB or not. If it is not existing, we are returning access denied, and if it is existing, then we are returning access granted from this function. Okay, so we can test this here as well. I'll show you. Again, in the response, if we see, it is publishing. So whatever we see, right, access denied or access granted, it is publishing this authorization message to back to the core service. Okay, in the AWS core service. So I'll test this and show you. Let me open up a new tab for the IoT code to show you how it is publishing the message. Okay. So it is publishing to the same topic. See, MQTT works on pub sub basis. Okay, publish and subscribe. Okay. think it's not, that option is not showing up. Oh yeah, here it is. MQTT test client. So here it shows whatever message you are publishing and subscribing. Okay. So we'll invoke our lambda function to see. And let's subscribe that topic over there. 1 minute. Okay, it's subscribed now. Now we'll again test this function. As you can see here, right, we are getting the access denied over here since we are passing the wrong ID. Okay. Let's get the correct ID from the DynamoDB database and test our function. And see, it's not restricted, like this architecture is not restricted to just one database. If you stick RDS relational database service over here, it is also gonna work and it's gonna scale to billions of devices. But my use case was very simple, so that's the reason I'm using NoSQL DynamoDB database. All right, so now let me pass this. So here you can see, right, this is the message that we are passing. Let's pass the correct message now. Okay, and I'm clicking on save. Right now, click on test and let's look at here. As you can see now, right, access granted shows up since we are passing the correct message. So that's how you can test the lambda function, and from there you can come to know that our business process is working fine. So we are granting access based on whatever users are onboarded in the DynamoDB database. So this is just the database, but the end application can also be hosted on cloud that onboards the user. Okay. So this is what the lambda function is, and it's also known as a function as a service. Okay, since we are writing just a function over here and invoking instead of writing the whole application. Okay. Okay, moving to the next part, the IoT, in the IoT core, I'll show you how the whole cycle works. Okay, how it is triggering uh, how the complete mechanism works. And all these services that we are using, they are completely serverless and they are very highly scalable. So under things, we have our IoT device. Okay. So in our lambda function, we have written a trigger. Okay, that triggers a message to ESP like this IoT device. Okay, so let me open first that lambda function. So from the lambda function, it triggers a message out to the IoT core. So under configuration, there is a trigger section. Okay. And as you can see, it is triggering and a rule, okay, to IoT. So we have defined an authorization rule. If you click on that, it's going to open the IoT core service and it's going to show you the rule over here. Okay. So see, we have defined a simple message. Okay. Select message from ESP8266 pub. So whatever message, it clearly means that, let me explain you in simple terms. It clearly means that get the message what is published to this topic. Okay, it gets the message, and what is the action? Action is lambda. So it sends out a message to lambda function. Okay. So I told you, right? When user scans the card, it sends out that RFID card number to this IoT core service, and this IoT core service triggers an action to the lambda function over here. So this is the lambda function. It triggers an action, and this lambda function reads out the credentials from this access card data database. It returns back and sends out, routes the message back to lambda. Okay. So this is the authorization rule I was talking about. And if you click on this, it takes you back to the lambda function. Okay. If there are any error actions, then also it's going to show you over here. So this is kind of a very simple architecture, but of course this architecture can be, integrated into any IoT device. Till now I used it to integrate around 4 IoT devices, and it has worked seamlessly well. And of course, for providing security, I'll suggest you to put IoT Defender on top of it, in front of it. So it's going to make this complete architecture, like complete it's going to secure your IoT device. Okay. So you can put it something like this. So in this architecture, I have already kept this IoT Defender service. So IoT Device Defender sits over here. Okay. Just before your core service. So it's going to protect your device. Okay. So I've not used it because my this was a simple demo. So, but in production use cases, you need to use that. Okay. All right. Moving to the next slide. These are the hardware components that we are using. Okay. So first is we are using Arduino Uno. Okay. We are using 16x2 LCD. We are using ESP01 Wi-Fi module. So this is the ESP01 module that you see over here. It is a tiny chip, and which is used to communicate with the Wi-Fi using Wi-Fi. Okay, this is the USB to ESP01 programmer that we are gonna use for our demo, and it has a tiny switch over here that you can use to move it to in programming mode or in normal UART usage mode. We are also using some jumper cables, different types of jumper cables. We are also using soldering iron and flux and coil. Okay. So yeah, in my next slide, I'll show you the high-level sustainable IoT architecture. So enabling remote device management. So if you enable remote device management and allow OTA updates, it's going to make your architecture highly sustainable. Integrating with cloud services to access further processing capabilities while ensuring security of devices and data at rest and in transit. So as I told you, right, if you use device defender, it's going to make your device highly, secure. And in IoT core service, you can also enable certificate. Okay. So the certificates in terms of security. This slide explains about the design for sustainable IoT device. Okay. So number one, in your hardware, IoT device hardware, you should use heat sinks for proper thermal management. High quality copper connectors should be there. You should use DFE framework. I've used this framework. It is very effective framework. So it is for design for energy efficiency. Okay. So using this framework, your device can run for days, your IoT device. Okay, without using uh, any further charge. It automatically manages the device power supply and all. Okay. Next is component that use low powered communication technologies. Of course, you should in your hardware design you should use components which are low powered. Components that use edge computing to filter and process data locally rather than consuming power to transmit data to the power hungry cloud computing device. Okay. Components that avoid hazardous substances by incorporating sustainable materials using conductive adhesives or other lead substitutes rather than soldering a component assembly. So I told you one example, right, in the initially that a company is developing some PCBs that do not require this soldering. Okay, just place that component power on the device and run it for few hours. It's not going to automatically solder those components. So that's how you can achieve the sustainability. Okay, using sustainable components is not always possible, though sometimes it is even the solution's biggest contribution to the sustainability. Sustainable components are important, but engineers also need to consider the larger context of the designs. IoT solutions, for example, can contribute enormously to sustainability because they make new, more sustainable business models possible. So the business requirements keeps on changing. Okay. So I told you, right, that IoT device should adapt those new processes, and using just few clicks, you should be able to use that same IoT device for different business processes. It should be like a plug and play. So see, like microcontroller module should be different, and you can based on your different processes, you can plug in different sensors to the microcontroller and achieve your new business processes efficiently. That's how it should work. Next comes the security. So AWS IoT provides its internal security using AWS IoT Device Defender. Okay. So this is a service that you can use. It's not mandatory to use this service, but of course I will suggest you to use this in production use cases. So this I will explain you this diagram. Okay. So device reports security metrics to IoT core. Okay. This data goes into device defender. Okay. And device defender, using this device defender, you can trigger remote operations such as deploying security patches or rebooting. So you can, let's say, if somebody is trying to hack your device and uh, you know uh, you want to deploy security patches immediately, then you can automatically trigger that using AWS Device Defender. Okay, you can also audit this cloud side configuration. You can detect device behavior, anomalies, and machine learning. I mean, using machine learning and with manually defined static thresholds. So you can define thresholds manually, or you can use ML to, you know, uh, define the behavior of your device. And also you can publish the alerts. You can publish alerts to these three services at the moment. One is CloudWatch. So CloudWatch is a service, uh, which contains alarms. Okay, alarms in terms of let's say if I have defined a threshold, like I told you, right, 100 degrees Celsius. If the threshold, if my if the device data passes that threshold, then uh, CloudWatch automatically triggers messages using SNS. So this SNS service is, you can get notifications on your cell phone or on your email as well using this SNS service. And also, of course, using the IoT console. So in the IoT console, in MQTT test, you already saw those messages coming up. So there also you can, get these metrics and monitor your device. So of course, you need to audit the security posture of the IoT resources across your device fleets to easily identify gaps and vulnerabilities. Use machine learning models to define your own device behaviors to monitor traffic from malicious IP or a spike in connection attempts. Get security alerts when audit fails or behavior anomalies are detected quickly, and take actions to minimize the operational risk. Okay. Uh, easily mitigate security issues through built-in actions such as updating a device certificate, quarantining a group of devices, or replacing default policies. So using this IoT device defender, what you can do is, let's say, if I have some devices located in some latitude, longitude, and those are kind of behaving suspiciously, okay, then using device defender and IoT, you can, update the firmware, you can turn off those devices, you can restrict those devices from public usage. You can perform all these action on a single dashboard, okay, using AWS IoT. That's what the benefit is. All right, so I'll start with the demo now. Okay. I hope everyone is able to see my screen.
Yes, Ujjwal, I can.
Okay. Let me know if you are able to hear the sound of this audio. Okay. This is a recorded demo. I'm starting it now. Hello, everyone. So here is the working demo of the AWS use case, IoT use case that we have developed. So let me first explain you what all components we are using. So number one is the LCD, 16 by 2 LCD module that we are using. It is a built-in controller in it. That is all connected using jumper cables to the microcontroller module that we are using. Arduino is the name, and it uses 80 mega 328 chip. The chip that you see over here, it can be programmed. Okay, it is powered by 5 watts USB, and of course there are some diagnostic LEDs that we can use to indicate if any fault arises in any of the module. Okay. Next is the RFID chip that we are using to scan the RFID card, and this is also connected using jumper cables. Okay, we see we are not using flex cables as such like this. So the cable you see over here is the flex cable, and it is it wears out, it gets worn out very easily. And that is the reason we are using this cables over here. Okay. Next is we are using ESP01 module, which is the Wi-Fi chip. Okay, programmable Wi-Fi chip, and this is the programmer, USB to ESP01. Okay, and there is a switch over here through which you can program. So if you switch it to programming mode, it's gonna enable the programming. Okay, and it can be inserted over here. If you place it like this, it can be inserted like this. Okay, and you can stick it to the USB port of your computer and use Arduino Uno to program this chip. And see, in our case, this is going to be a one-time programming, because next the firmware we will be loading using AWS Greengrass. Okay, and these are the two cards, okay, that contains the RFID chip that you can use for scanning. Okay, so again, remember, we have already onboarded these cards into the system, so they are now inserted, like the IDs of this card are inserted in the DynamoDB database that resides on the AWS infrastructure. So both of these cards are scanned, and one of the card is marked as invalid. So when you will scan that card over here in this RFID chip, it's gonna give you a message that access denied. Okay, so yeah, I will start the demo. I will scan the card and show you. Okay, now so I'll scan the card. I have this RFID card. I'm gonna put it on the scanner. Okay, so as you can see, the message that it prints over here is access denied. Okay, now let me try with the another card which is valid and which has a valid entry. Okay, so I'm pausing this video just to add some more details. So this access denied and access granted messages are being printed from the lambda function. So that lambda on the fly, when I scanned that card on that RFID chip, on the fly, it interacted with the IoT core service on AWS side. It connected, it triggered a lambda. Okay. That lambda grabbed the data from DynamoDB database. It checked my card details. Since it did not find that card details in the database, it printed out this message access denied over here. In this, in the AWS DynamoDB database. So I'm going to scan it again. Okay. And here you can see the message states access granted. Okay. So it reads out this message from AWS and prints it over here. So this is just, see, we have developed a modular design for this IoT device. Okay. Say like the LCD is connected using flex cables, like the jumper cables over here. Okay. Same with this RFID module. It is also connected using the jumper cables. And we have some diagnostic LEDs over here. So let's say if this RFID sensor wants out or it has a fault, then the diagnostic LED will blink orange light on it. Let's say if this LCD module driver is having the problem, it's going to show a white light over here. So that way diagnostic is using the diagnostic LEDs. It's very easy to find out the exact problem with this IoT device. And if there is any issue with any of the modules, you don't need to replace the whole microcontroller along with the other modules. You just need, you can easily remove the, let's say if you are having a problem with the RFID module, then you can easily remove it from the jumper cables from here and replace it. Okay. And again, using AWS Greengrass, you can also update the firmware onto this. Okay, on 80 mega 328 chip. It's going to be OTA. You can also monitor these devices. And again, let's say if these devices are located in different regions like Asia Pac or Americas. Okay. And let's say you have some security firmware that needs to be applied to the Asia region. Okay. Then using AWS Greengrass, you can do the same. Okay. And yeah, of course, these are kind of the jumper cables you will require to connect these multiple modules. Okay. And you will get this two set of RFID cards when you buy this RFID module. Okay, it's very cheap. You can get it from the market. And again, this 80 mega 328 chip is also available externally. So you can, if you want, you can build your own microcontroller even without using the Arduino. Okay. So this whole module, right, whatever you see over here, which is, it contains LCD module, this microcontroller and this RFID chip. This is just responsible for printing the message, okay, and sending out the RFID data to AWS. Okay. The communication is fully handled using ESP01 module. Okay. The RFID chip that I just let me see if I can show it to you. I think I already did. So using that ESP01, you can. So this is responsible for communication. Okay. So we have segregated, this whole device into different modules. Okay, so this is responsible for communication. Only this tiny chip that you see over here. Okay, and you can connect. See, currently I've connected it using USB cable. Okay, but you can use a loopback cable to connect these two. Okay, ESP01 with 80 mega 328. Okay. yeah, that's it for the demo. So thanks. All right. So next I will walk you through the code that we have written written as a firmware of this, both with the modules you saw. So, oh, sorry, this is not the one. Okay. So first one I'll show you with the communication module, that tiny chip we saw, right? ESP01, that's what we call it. So that chip is being loaded with this firmware, okay? And that chip is responsible for communicating to the AWS, okay? So first, let me show you the configuration section. So config contains the thing name. So the thing name is the ESP8266, what we see in over here in the AWS IoT. The thing is ESP8266 under things. Okay, so this is being defined in the configuration. All right. Next is the SSID. SSID is my Wi-Fi, my router's SSID. Okay, so this is my SSID and this is my Wi-Fi password. Of course, this is not the correct one. I just replaced it, but this is the Wi-Fi password. Next is AWS IoT endpoint. Okay, the endpoint that you see over here is the AWS IoT endpoint. What you get after you create this thing. Okay, so after you create this thing, you will get an endpoint that you need to place it in the configuration. Okay, configuration over here. Next is the certificate. Okay, so the certificate data needs to be kept over here. This is highly secured. Okay, so that's the reason we need to put a certificate in order to communicate with the IoT device. So if somebody gets this URL, as you can see, we are not passing any credentials over here for connecting to AWS IoT. Of course, we are using this certificate in order to authorize the device. Okay. So where you get this certificate, you will get it from over here under the certificate section. There is a certificate ID. We already clicked on create certificate and we got this ID over here. Click on that. It's gonna, of course, when you initially, create the certificate, it's gonna return you 3 files. You need to keep all the content from these 3 files over here. So one is Amazon root certificate, which is this. Next is the device certificate and device private key. So these all 3 key things will be required in order to communicate with the endpoint. So let's say tomorrow, if some hacker gets this URL, he won't be able to use it unless he gets all these 3 certificates. So that makes your device highly secure. Okay. And of course, you can also, let's say if your device certificate gets compromised tomorrow, then you can also update the certificate on the fly using AWS Greengrass. Just a few clicks will do the job. Okay. So that's the config part. That is the configuration part which contains thing name, SSID, endpoint, and certificate. Okay. Going back to the code over here, we are including the config file over here. We are including the ESP8266 library, which is the library that is used to communicate with the microchip that sits in the ESP01. The Wi-Fi secure module, like the Wi-Fi secure library, MQTT client. Okay, because the MQTT server is this. Okay, what you see over here is the server in the AWS IoT. We need a client, so that's why we have imported the client library over here. Okay, and this is the JSON because the lambda is returning us the JSON output. So in order to process the data, we are using Arduino JSON over here. Okay, these are the topics that we are using. I told you, right? Publish and subscribe. So these are the topics that we also need to put this in our firmware code. Okay. And we are initializing the Wi-Fi client and MQTT client in objects over here. Okay. We have this connect AWS method. So this method is responsible for connecting to AWS. First, it connects the Wi-Fi, okay, with the Wi-Fi password and user ID. it connects to the Wi-Fi, then, for some checks are happening over here just to see if Wi-Fi is correctly connected or not. Okay. Then it sets the certificates, all the 3 certificates over here. Okay. In the client. See, this Wi-Fi client is responsible for interacting with the IoT core, because this is the communication channel. Wi-Fi is the communication channel. Okay. So it needs to pass this certificate data over there. Next is we are beginning the IoT endpoint, what we have in the config over here. This is the IoT endpoint. So we are initiating the connection to that. And this is the port. This is the common port. We cannot change it. And we are passing the certificate data over here using the Wi-Fi client object. Okay. Then it's going to connect to the AWS IoT. It's going to print out this message. And of course, if IoT, see, it also subscribes to this topic. Okay. And it prints out this message. Next is we are publishing this message. Okay. So let's say somebody is scanning the card. Okay. Then this method is going to trigger. It's going to publish to the AWS IoT. And of course, we are also handling the incoming message. Incoming messages will be access granted or access denied. That are also being written from the lambda function. Okay. See, this you will require serial.begin. And remember, if you have modular design, make sure that both the devices are using the same baud rate. This is the baud rate we call the serial port connection speed. Okay. And yeah, we are invoking the connect AWS method and we are publishing the message. And there is a delay we have kept over here just to make sure that we are not, we are not calling this service again and again. There has to be some delay. Okay. If you don't put this, then there was a problem that was coming. That's the reason we have kept this delay over here. Okay. So this is the firmware that we are using for. I'll show you what component we are using. So this you see over here, right? This is the firmware for this module. Okay. Next, we'll move to the LCD module, the microcontroller part. Okay. What we have it over here, the LCD, Arduino Uno, and this RFID. So this is a separate module. So we have developed a different firmware for that. Okay. So starting from the top, we are using this SPI and MFR C522. So this MFR C522 is the RFID chip. Okay. So this is the library for this chip. So to interact to that RFID module, we need this library. Next is the liquid crystal. So this is the LCD. So in order to interact with this LCD, we are using that library. Okay. So yeah, we are initializing the variables over here. We are using serial port to connect. Okay. And again, we are checking in the serial, right? If any message is available, then initialize it in the incoming string. Okay. And print it in the LCD. So the access granted message, right? It prints it using this functionality. Okay. It reads it from the serial and prints it over here. And there is a delay we have kept over here. We don't want to print get data every time like simultaneously. So we are keeping a delay over here. This is for checking the cards. Okay. Like if you scan the card, okay, it checks, it returns it from over here. Okay. If not, if there is no new card present, then it simply returns it. Okay. And of course, it parses the data from that card, whatever the hex string we saw, right? A2, B2, C2 that we have stored in the DynamoDB. It parses the data over here and it converts into uppercase and simply it passes in the serial port and prints it on the LCD. So here we see, right, cursor 000. 00 means on the top one, the first line. Okay. The first line is 0, 0, 0. If you want to put it in first row, then 0, 1. Okay, in the second line, it will print in the second line. So that's what is the objective of this. Okay, of this firmware. This firmware only prints the messages on the LCD, and of course, it also sends these messages to, like, whatever the card you scan over here in the RFID, it sends the data to the ESP01, which is used to communicate, and this sends out the data to AWS. Okay, so that is what the object. The reason why we kept the modular design, because I want to show you the sustainability, how we can achieve the sustainability. So see, if everything is integrated on a single PCB, okay, the communication module, LCD, RFID, and what's going to happen is, if a single part fails, you got to replace the complete PCB, complete module. And let's say that is, the companies don't repair often when it's out of warranty. They usually prefer for a replacement, or you got to buy a new product after that, after the end of life, like not end of life, but out of warranty. If it is, even though it is in warranty, they replace it. So that's the reason for the modular design. And see, we are using trigger mechanism. So it's not always communicating with the AWS IoT. Okay, it only communicates when a new card is detected. So whenever you scan into this card scanner, then only it's going to communicate with the AWS IoT and get the data from DynamoDB and print out this message. Otherwise, the device will be idle. Okay, so here you can, like, in order to improve the power efficiency, you can use this DFE, what I explained you in the earlier slide. So design for power efficiency. Okay, it was somewhere over here. Let me find out. Yeah, DFE framework. So here you can use the DFE framework, design for power efficiency. And of course, we can also use heat sinks over here. Of course, even though this device is not heating, but it's better to use heat sinks. And proper packaging should be there. Like, if your device should be properly packaged so that moisture does not affect it. And yeah, that's the reason we have kept this modular design. So any questions so far? Anyone? So how many of you are well versed with AWS? Like, have you used AWS anytime? Like, are you aware about Lambda or anything? Any of those services? Or is this completely new for you, like the AWS part?
Ujjwal, Shirish here.
Yeah.
So I mean, couple of services that I'm aware about, but the green grass and the core IoT that are new to me. But I mean, for example, EC2, DS3. I mean, those are I'm familiar with.
Okay. Okay. Great. Okay. Next, I would like to show you one more cloud-based, framework that you can use, which is Arduino Cloud. Arduino has its own cloud. Okay. So you can use it for designing and developing your firmware, and also you can do the same kind of things as you do with the AWS IoT, but it's not that much functional. Like, the functionalities that AWS IoT core service provides, this Arduino Cloud provides very limited functionality. But to give it a try, you can try this. Like, let me show you. So here, like, you need to log into cloud.arduino.cc/home. Okay. So here you can develop your cloud applications using web editor and IoT cloud. Okay. So Whenever you write any software for like a firmware for this Arduino, we call it as a sketch. Okay, so you can start with a new sketch, or you can also use web editor over here, and it performs the same kind of thing what I told you, right? You can upload the firmware over the air, OTA. Okay, so you can write your firmware over here. You can use Arduino cloud itself to upload that firmware to your IoT device. So as an initial trial, you can use this. It's very easy, and there is also a free version available in order to use this. Of course, it provides limited storage space for your sketches, but that's enough for a beginner at a beginner level. Okay, so just give it a try. It also provides this monitoring, what I told you, right? See, it says serial port not available. If I have a device that is attached to my laptop, it's gonna show the monitoring window over here. Okay, and this baud rate I told you, right? You need to set the baud rate and good to go. And the great thing about this is you don't need to download any of your library. Like I told you, right? If I'm using Arduino IDE, then over here I need to download all this and this MQTT library. So I need to download this from GitHub. I need to download this from for Arduino JSON from GitHub and integrate that in my Arduino IDE. But here in the cloud, it's very simple. You can simply click on include and it's going to include it over here. See, no need to download anything because this library is like takes some time to download and integrate on your Arduino IDE. And of course, the compilation also takes a time if you are performing this on local. So this is very easy to manage. So I found it great. But of course, it has very limited functionality. Don't compare it with the AWS cloud because AWS cloud provides a lot of uh, functionalities as compared to this. But as a beginner level, you can try that. It also has integration with the machine learning tools. Okay, I've not tried this, but it is quite similar to what AWS provides. Okay, that's what I got to I came to know from the documentation. Next is the API keys. Okay, so like what we saw over here, right? Like we are using this certificate in the configuration. So there are certain keys. Instead of these certificates, the Arduino cloud uses this API keys. Okay, that you can integrate it over here. So this is great. You can go and discover this. It's a great tool. And yeah, next is See, I'm using this architecture tool through which I used to design all my AWS architectures. So this is a great tool, online.visualparadigm.com, and there is an AWS specific AWS option over there. It provides a lot of it supports a lot of other cloud platforms as well, like Google Cloud, Azure. Okay, so I found it great. So in case you are designing your architecture, then you can use this. It is a great tool. Okay. And one more thing I would like to say, like when I was connecting to my, like when I was first time, preparing for this IoT device, I got an error. My IoT device kept on disconnecting with AWS IoT, and I was getting client error. And there was no blog, no one. Even I connected with the AWS support, and they were also not able to help me with that. We spent around 7 to 8 days to resolve that issue. But after I posted my question in the repost.aws. Okay. So this is a great blog in case you have any questions that are related to IoT or any of the AWS services, you get a very quick reply. So even I had a paid support for AWS. Okay. I have paid support for AWS cloud. The support team was not able to help me for days, but using this repost.aws, I got a very quick response and I was able to resolve my problem. So if you get stuck with any of the AWS services or in AWS IoT cloud, then you can use this. This is a great support kind of thing, and it's free. You don't need to pay for anything. Okay. So basically, the issue was related to the policy that I had defined. Okay, and because of that policy, the device was not able to connect to the AWS. I was getting client error continuously. So I was getting something like this: disconnect reason client error. There was no stack trace, no explanation was there. And even in the AWS CloudWatch logs, I was not able to get anything. So I posted this question with the code and details, and they suggested me to go through my policy document. So it was denying earlier. Okay. So you see here, using this policy, you can deny, publish, subscribe, whatever you want. Okay. So let's say tomorrow, for some of my devices, I want to stop them from interacting to my IoT cloud, or if they are compromised, then I can quickly go in my policy and, instead of this effect deny, if effect allow, I can change it to deny. So the publishing workflow will get stopped. Okay, and my device will not be able to communicate. But since I was having deny, I was a beginner at that time, and I had some deny over here. Because of that reason, it was not able to communicate. So after correcting the policy document, it started working, and of course, uh, uh, I was able to use my device. So let me show you the device policy. So that this is the most common problem that everyone comes up. The disconnect reason, uh, like as per this blog, where is that blog? Yeah. So it disconnects. It keeps on disconnecting without giving any proper error. So you can resolve it by you know solving your policy. That's it. So the thing, so here is the policy. Okay. So this policy was having a problem. I had some deny over here. Okay. So in the publish, I had that deny in the fact. Okay. So I made it to allow all, because I want to connect to the AWS IoT. See, these are different policy sections. Okay. One is connect, next is subscribe, receive the data, and publish. If you have any one of them stating as deny, your device won't work. Okay. And of course, it also keeps the versions of your policy. If you want to find out who modified the policy, then you can look out for the previous version, and the current one will stay as active. Okay. So yeah. So that's it from my side. I think if you have any questions, you can
Yeah,
ask.
usual. Pawan here.
Yeah, Pawan.
Actually, this is for Android device. AWS IoT. AWS
Yeah,
IoT Core is for Android device.
yeah. If you have any Android device, let's say, see, I have a device known as Raspberry Pi. Okay, you can load Android or you can load Linux, whatever the device type is, you can use it. Use this AWS IoT on that. The operating system can be anything. It doesn't matter. You can use it with Android as well. It will work. Any further questions?
No, sir.
Okay, then if we don't have any further questions, then I think we can close this call. And if you like this session, then to give your ratings on Gary. I would like that. And one more thing I wanted to share. Let me see. And of course, yeah, I will post all this code and PPT links, or we'll share it through email to you, so you can take a look at that. And if you have any questions, then you can reach out to me related to any AWS query, like anything, any service in AWS, you have any query, you can connect with me. I will be glad to help you all. Okay. Yeah, so that's it. Thanks for attending this session, and I hope you liked it. Thanks again. Yeah. Bye.
Thanks, Ujjwal.
Thanks, Ujjwal.
Thanks,
Thank you.
Ujjwal.